Cool. Okay. So let's get started. How are you guys doing?
Great.
Is it good? I see there's like a kind of a front to back kind of feeling here. You're unfortunate enough to live in the front row. Welcome. First, I need to explain your laptop. I've been given the task of trying to give a talk here about how to write a great research paper. This is a formidable task. So instead, I think I'll just talk about something else. I'll talk about. I'll talk about how to be a writer. Anybody know how to be a writer? Are you writers? It's actually really simple. First step is you need to hate yourself, and then you need to drink, and then you just keep drinking. This is the cynical view from the oatmeal. So being a writer is actually not that hard. So maybe let's go back to the original topic and talk about research papers. Right? So this is a skill that all of you are going to have to excel at. Right? So how many people have tried writing a paper so far? Ah, yes. So you know what's coming here, right? So you probably know that a lot of the stuff I'm going to tell you already know, right? And you also know that some of the stuff I'm about to tell you, you know you should do, but you don't. Yes? Nobody?
Yes.
Yes. So these are the lessons that are so valuable to come back to because, like for instance, like in just researching this talk and stealing the slides from whoever wrote them first, it was like, oh yeah, this is a good idea, and like, oh, I should do more of that and so forth. It's an art form, right? Communication is an art form. So I'm going to bombard you with a bunch of interesting thoughts from people who have written great research papers, hopefully with you taking away some of that information in your own writing. So let's just go through it. So it's a skill. I mean, it's truth that a lot of papers are badly written. Tons of papers are badly written. I mean, you've seen them, right? You've looked at papers and be like, what is this garbage, right? Please don't be one of these people. But it also marks an opportunity. You can be better. You can write better papers than that. It's a skill you can learn, so that's a good thing. You're not born in this world with like a full skill set of just being able to write on a research paper from the get-go. It's something that's kind of like learning a programming language, right? You're trying to learn the interfaces, the nuances, you're trying to understand your audience, you're trying to express complicated concepts and somehow linearize them into writing. So it's something that's really a skill that you pick up. And it's worth learning for several reasons. One of them is that you get more brownie points, you get more papers published, you're going to get pretty much a lot of your career is going to depend on being able to accurately write. You're also going to be able to have more impact with your ideas because people pick up the paper and they won't be like, what is this garbage, like before, like you guys did to those other papers, right? You're going to be like, oh, this is so beautiful and prosaically written. And you're like, you just read it, right? I mean, you know these papers that are kind of like, just like, shh, hold on, I'm reading a really gripping paper here, right? This has happened to you? It's happened to me maybe twice. But it's possible. And there's some people who are prolific writers like that. And here's another thing that's worth thinking about, is that you actually have better ideas through writing. So we'll come back to that point. So this is the canonical view of how you do research, right? You're like, oh yeah, I just need to come up with like an idea. Okay, I'm not going to do all the research, and I'm going to keep doing this and so forth, and then like, at the end of it, I'll write a paper, right? And this is what you usually thought, right? Well, I'm going to dispel that. I'm going to say like, well, actually, there's another model here, just to make it dramatic. Like sound effects in your head, right? If you instead come up with an idea and then start writing the paper as you go, what happens? What does this force you to do? It forces you to think about what you're putting down. It actually forces you to think about the problem in a particular way. And in doing so, you'll actually figure out the things where you don't understand the thing. So for instance, if you're in front of your LaTeX editor or something, and you're trying to write something, and you're like getting into this section, and you just really, really want to go on Facebook or the news site and then check something else out, right? What's happening? What's happening is that you're faced with something that you need to decide on, right? There's something that you can't put into words that is uncomfortable, so it's easier to just go back to like checking and say, is there something on Facebook? What about now? Right? You know this feeling? So this actually means that you need to take a step back and be like, okay, what is it that I don't fully understand about the thing I'm writing about? What is it that I need to define better or make more crisp so that my writing is more clear? This really forces you to think about the problem as well. Another thing is that if you write these early drafts, it's easier for you to circulate them to your colleagues and to your buddies and to your professor and whoever, just to kind of get feedback earlier. And this is how some of the top schools do a lot of the research. They're like, oh, I have this idea, I have like a 2-page write-up already of like what I'm thinking about, or some of the limitations of stuff that I don't understand. Can you have a look? And then people just get involved. Right? That's actually how paper writing used to happen back in the days, is that you would circulate this like technical report, and a lot of people would add stuff to it, and eventually it'd be like perfect enough and it would get published. Right? Sometimes it didn't even get published, it was just this technical report over sent. So it's a really good way for you to do a reality check, to collaborate, and to criticize what's going on. Now regarding that idea aspect, there's a fallacy that you're going to be like, oh, I have one chance, I'm doing my PhD, and I'm going to need to come up with this idea, and it needs to change the world. It needs to be the next Nobel Prize, right? There are advisors who also push that type of stuff, so stay away from that, right? You're not expected to have the groundbreaking idea and everything like that, right? In fact, ideas are cheap. It's easy to come up with ideas, and they don't have to be particularly good. They're a part of a process. In coming up with an idea and refining it through writing, you'll come up with the next idea, and you'll start to understand things better. And eventually, you're going to make enough leaps that you come up with something that people feel like, that's a pretty original thought right there. Pretty original idea. So you don't need to have a particularly fantastic idea before you start writing a paper. You can start writing about the things that are on your mind right now, right? I think this is a good problem. You start writing, and then realize like, oh, okay, actually, maybe it's better framed like this or that. It's you talking to yourself. In some sense, one of the things I want you to walk away from this talk is that writing is communication. This is how we talk, scientists, right? We write papers and we read papers. They don't have to be this artifacts that are just like this prizes that you wear, like this sort of what do you call this, like things that you put on your jacket if you're military. I forget what they're called. Banners. They're not like these things that you just keep around. They're actually method of communication. So, in writing things down, you could in fact take any idea and develop it, right? So write a paper, give a talk about any idea, no matter how weird or insignificant it may seem to you. This is actually a really good idea. And this is something that I've also mentioned to some people here, is that something just to add to your own routine. Take 2 hours a day and just write. Doesn't really matter what you write. Just get into the habit of writing. So it's such an important part of your job. Could be one email to your professor. It could be something developing an idea that you have. It could be just summarizing some of the literature you've been reading, right? Just getting into the writing aspect will help you, and it will make you better at it. Right? Just like you program, right? You have to practice program, same thing with writing. So don't be intimidated. This is how you develop the idea. That also helps you understand the problem space itself, right? So, also when you flesh out an idea, you'll understand maybe a little bit better the relevance of the idea, right? So you start to see just like, well, okay, there's this idea, but this is really incremental, right? It's improving on something that nobody really cares about. Like, you start to see how it fits into the bigger picture because you have to express it in the bigger picture. You need to have motivation, you need to have an introduction, and so forth. So you actually get to see just like, well, actually, am I solving a real problem here, or do I just have a solution that I really wanted to use this hammer, and I'm just looking for a problem? This happens a lot. In fact, a lot of papers published are solutions to the problems. Writing early actually helps you move into the space where you're solving real problems if that's what you desire to do. It's a very motivating thing to do. Now, with that said, and feel free to just jot in with questions. The only kind of, yes, go ahead.
What kind of writing are you talking about? Because as far as I know, writing a paper, it has its own rules and regulations.
Yeah.
I have an idea, for example, from where to start.
So, here's the thing with writing, is that rarely what you start writing will be in the finished product, right? Suppose you're starting to write a paper. The first things you write are probably not going to be in there, right? But they don't have to be in there. It's a part of the refinement of writing. Just like when you're coding and you make your prototype is not going to be in the final product, right? So it really doesn't matter. Just write something that kind of is summarizing your thoughts or is expressing something in a logical fashion. And you have to decide on it. We'll go through that in this talk about who's your audience at a given point in time. So to start with, when you're writing an idea, it can be this kind of a little bit informal, like here's like the structure of my idea, here's how it fits in. And then as gradually you start to think about, okay, suppose I have to structure it into like an introduction where I can talk about why it is relevant, where I can formally define the model that I'm working within, what is the idea, what is the problem, and I start to think about examples and so forth. All these things start cropping up as you develop your writing. Does that make sense?
Yes.
More questions? I'll hand out these slides if you like, so that you can come back to them at some point. But yeah, there are a lot of interesting points that have been put in here that I would like you to take away. Now, why do we bother with writing in the first place, right? So there's this fallacy here that the reason why we're in science and the reason why we do all this writing and so forth is that we're kind of, it's brownie points, right? We're giving talks to impress others, we're getting recognition to get promoted, right? Here's Calvin Hobbes saying, I used to hate writing assignments, but now I enjoy them. I realize that the purpose of writing is to inflate weak ideas, obscure poor reasoning, and inhibit clarity. Full of practice, writing give an intimidating and impenetrable thought. Want to see my book report? The Dynamics of Interbeing and Monological Imperatives of Dick and Jane, a study of psychic transformational gender rules. Has anybody seen papers that are completely indecipherable like this? Oh, yes, you have, right? It's really easy to cloud your ideas, and people do this both for papers and for talks. That somehow you feel unsure or you lack confidence in what you're talking about, and so you try to make it look more impressive. Right? It takes some guts to reveal the simplicity of the things that you're doing. To go in and talk about, here's the very basic idea right here, and we did all this stuff. Of course, there's a lot of work leading behind it, but you're just there trying to inform and educate the reader or the audience of your talk. It provides so much more clarity when you approach a paper or you approach a talk like that. So you don't have to make it look and sound very impressive. You just want to be precise, but you want it to be readable. So good papers and talks are a fundamental part of research, actually, as we know. Okay, so this is something I already mentioned. Papers are our means of communicating ideas. And then when you sit down to write the paper, have that be one of the first thoughts that goes into your mind. You're communicating. Which means that you are writing down words, you're taking some of the stuff happening in your brain, and you're kind of codifying it into words on a sheet of paper to be read by some person like you, and then put into ideas, right? So any kind of, for instance, when you introduce needless notation, all you're doing is that you're putting all this needless notation on a paper, and then some other person has to take all the needless notation and get the same kind of mental structures as you did, right? Why? Why the needless part, right? Put down everything that is needed for a person to be able to reconstruct your thinking, or to reconstruct what they need to understand about your problem. Right? So you need to think about who the other person is. Whom are you writing to? So something just something to keep in mind as you're writing is that the person on the other end also doesn't have to read what you're writing. It is in some sense your goal to try to get them to be excited about what you're doing. Because if you're not excited in doing that, nobody else is going to be. Right? So you try to infect the mind of your reader with your ideas like a virus, right? You're hacking the reader. You're like, ah. So you're trying to be, you're trying to take the reader from what they know into what they don't know in a very gentle but exciting journey. Does that make sense? So it's also worth noting that your papers are going to be far more durable than programs, right? Think about Mozart, right? And the final point I want to make about this slide is that, and this is a tendency usually more common outside of academia, is that there's this tendency of you having an idea and you think it's such a great idea, but you're not going to tell anyone. It's your idea. Somebody might steal it. Okay? But really, 99% of the work in making an idea a reality comes after the idea. Right? It's 99% perspiration, 1% inspiration. Right? So, in fact, the best thing you can do with an idea is actually to share it and talk to other people about it and get feedback and develop it, because other people will see something you didn't. Okay? So the greatest ideas are literally worthless if you just keep them to yourself. And ideas are cheap. You come up with a bunch of ideas. Something that I started doing is to just keep around like an Evernote or something. When you have an idea, that like those 15 seconds when you're like, oh, I have an idea, you just like kind of grab it, put it down into like Evernote, because after those 50 seconds and you go back and it's like, oh, I had an idea about something. Yeah, what was it? Oh, I have absolutely no idea right now. So keep onto them, develop them, share them, and write them up when you have them. Okay, so let's talk about another aspect of when you're writing a paper. You're teaching someone. So instead of you just communicating, you're actually trying to educate someone in a respectful way. So when you are doing that, it's important that you don't just start off with like, well, when you and then nobody's going to know why they should care, right? You just start with like, if the first word of your paper is theorem, you're doing something wrong, right? Right? So you need to understand, like, give some context for what you're doing. You need to give the person some idea about what you did, why you did it, why it's important. And then also, a paper needs to express how it works. Otherwise, it's just a marketing white paper, okay? So, the best written papers are the ones that also contribute something that helps people understand the topic that you're talking about a little bit better. You know these papers, right? When you read a paper and you really learn from the paper, right? Everybody has a favorite paper like that, and they treasure them. You could write those papers too, where you invest enough time to make it so that it's giving the person additional information about how things work and putting things into context, because you've painstakingly spent an effort of making you yourself understand. So this idea, what is an idea? It's something that's a reusable insight that the reader might be able to apply in different contexts. That's what people may latch on when they read your paper. There's a lot of recycling in science, and I'm sure you guys all know this, and you read a paper in one field, and then you read a paper in a different field, and then, oh, I could use that insight over there, over here. Oh, I hope they don't discover that I just mixed these two things together, and then you write your own paper about like, oh, they're mixed together. But that's realistic how most of science works. It's that you're doing a lot of recycling of ideas that are subtly different. And of course, you yourself, you always view it as being this kind of very incremental progress, and you kind of know exactly where it came from. But to the outsider who's looking at the progress, you feel like that's a really cool thing that you've done here. This is why imposter syndrome is so prevalent. It's so easy to understand where you came from, and you feel like it's so insignificant. But that's how all of it works. So, reusable insight. So when you're writing down, the first thing you need to do is to try to figure out, what is that insight? What is that idea? Try to discern it, distill it into its rawest parts. And that's going to be the backbone of your paper, is that idea, one idea. So, by the time the person has read your paper, there should be absolutely no doubt that they understand that idea, right? You should not sweep it so far under the rug or embed it so deeply into the narrative that it's impossible to discern from a quick reading of the paper what the idea is. You should in fact just expressly state what the idea is, because why not? The main idea of this paper is, or in the section we present, the main contributions of the paper. Just be explicit, why not? It provides clarity. And this is something that you also notice when you start reviewing papers, is that this is an extremely common mistake. People present a system, and then you're like looking at your reading system, what's new here? Like, what is the idea that I'm reading about? What is the delta over previous? So, one P. That's another way to look at it. Your paper should have just one P, one clear, sharp idea. And when you read your paper again, after you have painstakingly written the paper, and you read it, can you, or someone else who's reading the paper, discern that one idea, that one P? This also speaks to a different thing, which is that there's this tendency of being like, oh, I need to get a paper at this conference, and it's such a major conference, I'm going to put 15 ideas in here, right? And you have this like massive like house of cards of ideas and so forth, and you try to like shoehorn it into this one paper, and it's only like 12 pages, so you like step on it, and you try to like shove it in, you have this indecipherable mess at the end. You're like, people are looking at it and be like, okay, there's probably a lot of good stuff here. I don't understand these parts because I never explained. We didn't have space. Yeah, I don't know. This is too much. You probably need to separate it out. That's a common criticism that you also get when you like sit on too many ideas and you just like try to create this monstrosity of a paper. Just be simple. One idea, one paper. Right? Any, well, no questions. Just be honest. Okay. Good. Any questions? Okay. Yeah, so you may not know exactly where the paper is going at the very beginning, but by the time you're done, you must know what that means. Okay? You have lots of ideas, read lots of papers, although try to steer clear of the least publishable unit. One idea per paper is fine, right? But there's, in academia, because some of the metrics are maximize the number of papers you have, so you're like, oh, this idea, I actually would write 2 papers about this one idea. Just be honest. Write a paper about the idea. Don't write 2. Now, the purpose of the paper is not to describe, say, a system that you wrote. Like, I'm describing the WSWAS system, right? Your reader doesn't have a WSWAS. What is a WSWAS? It's irrelevant to this discussion. Why is the person reading this thing? They don't care about WSWAS. They care about the process that went into coming up with WSWAS. They care about the idea behind WSWAS, right? Because it's that reusable insight that is of value to the reader. That's why they're reading this paper. You're not writing just documentation for a system you wrote. It's not an API reference. It's a scientific contribution. So make sure you know what the science is. Okay, so now that we've talked about why on earth you should be writing papers, let's talk a little bit about how it flows. Any questions up to this point? You can ask a friend. No. Okay. So, here's a problem. The first thing that's in your paper. There's a problem, right? It's a call to arms, right? It's an instant kind of, it's a hook to get the reader interested, right? The hook is not theorem, call it, right? The hook is something that's like, something is wrong with the world. Sometimes it's a little bit like, there's been a meteoric rise of cyber attack, and like, it can be a little bit dramatic. But it's usually a hook that gets you at least interested in what's going on. It's a problem. And you're like, oh, okay, I'm reading this paper, and it's like, oh, there's an interesting problem right here. It's being explained to me right here that it's very interesting. It matters in the world. It fits in. It's a real problem. Oh, and it's unsolved. Wow, people have been trying to solve similar things, but not this particular problem. Oh, I wish I knew how to solve that. That's what you want your reader to really experience. And this is a part of your introduction, actually part of your whole paper throughout. You want to be like, oh, I really wish I could solve that. And then you embed, here's my idea, my contribution to this thing. My idea is that we're going to tackle this problem in the following way. And here's some rudimentary details about how it works in the introduction, and then throughout the paper you're filling in some more of those details. And the reader's going to be like, oh, I see how that works, that's ingenious, that's so cool, right? Of course, you don't want to get your reader to be like, I have no idea how this works. That's not a very useful paper to have read, right? You want them to understand. And then finally, here's some idea compares to other people's approaches, right? Which you've already kind of talked about in like, that it's unsolved and so forth at the very beginning, but you should elaborate on that in your related work and in your comparison or your experiments and so forth. Yeah, makes sense? That's the narrative of paper. This is not the same narrative as you would have if you're writing a novel, right? Novel doesn't something. It starts with a hook, sure, but it doesn't have the structure. So we have a lot of, it may be a boring structure, but it's an extremely effective and useful and common one in science to have it phrased up this way. So it's also very helpful to have this kind of template because when you're writing your first papers, you kind of know what needs to go where and so forth. Now, characterizing your reader. This is one example of a potential reader. I feel like this is reviewer number 3. Anybody know reviewer number 3 jokes? It's the person who always rejects your paper. Yes. Okay. So what could you assume of your paper, right? Well, you have to assume that they have some technical knowledge of what you're doing. You shouldn't assume that they've been in your head and fully understand everything that you're regurgitating onto paper, right? You need to have some idea about your preconceptions about what they know, what they don't know, who they are, so forth. and about your interests, right? When you are working in a particular field and you attend conferences, you start to kind of know the audience, right? You know the people who would probably be reading your papers. You kind of know what they know and so forth. And it becomes easy. But at the beginning, suppose you're sending a paper to a conference you've never submitted to before. Well, then you should just look at who's on the program committee. What kind of work do they do? Looking at the work, you get a pretty good idea, like, oh, they're working on these types of problems. Or, oh, this is the kind of style that they like. Well, let's read some of their papers, right? What are the topics and assumptions of papers previously published there? You're starting to work in security and like, oh, notice that all the security papers, they always have a section called attack model. Right? You're like, oh, that's curious. Well, that's a very good way of putting it. Well, apparently that's the style in that community. So you adopt that as you write paper stuff. Make sense? So, something about the audience here. If you look at your conference paper, which is what you're probably going to spend most of your time writing, you're going to be writing an abstract. And the abstract is going to be written, actually a title first. The title is going to be seen by a lot of people. It's going to be seen by everybody on the PC, and they're selecting what papers to review. It's going to be seen by everybody who kind of scans past it in search results. It's actually going to be the string that people search for in Google, right? Google Scholar. So if you call it like big data cloud security, a lot of people are going to see it, right? Don't hack the system for that. So there's something to keep in mind. And then there's the abstract, and that's what most people will start reading. Suppose I'm a reviewer and I'm reviewing your paper. First thing I'm going to read is the title and then the abstract. The abstract should give me enough information that I kind of have an idea about what your paper is going to be about. We'll talk about how to structure an abstract. So it's 4 sentences, 100 readers, and then there's the intro. People like the abstract may continue to write the intro. Maybe slightly if you will read the actual intro. In systems paper, a lot of people try to read the abstract and then they start looking at the figures in the experimental section. This is what that community likes. Introduction, 1 page. That's something that I see a lot of people deviating from, but there's rarely a reason for you to have more than 1 page for an introduction. Usually it's pretty much the same 4 sentences here expanded into 4 paragraphs. Then there's the problem. Hey, what's the problem that you're solving? Could be motivation, whatever you call it. And then there's your idea. What are you bringing to the table? A couple of pages on that. And then you're down into 10 readers for each. Then there are the details, blah, 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 theorem, whatever. 3 readers maybe. One of my most highly cited paper had like a very glaring error in the details. And I found it years later. Nobody pointed it out to me. None of the PC caught it. Like, nobody seems to have really read it. Because it was irrelevant to like what people were doing. So I had to catch a mistake like, there's a big error, right? So the details are the bulk of your paper, and there's very few people going to read it. It's also a fairly good place to start working. When you're working on your idea, you're usually working within the details. And so when you start your writing, maybe start working on some of the implementation section or design or some of the things that are in the details. And then you can start expanding in the other direction. And then finally there's a related work section. It's maybe 1 or 2 pages. Again, they have up to 10 readers over here. And then there's extremely short conclusions in further work section. And really what the conclusions further work are effectively mirroring the introduction. Just in a kind of more concise way, commenting on some of the development that's been made throughout the paper. Make sense? That's a paper. So if we go through, yes?
Is that the right thing to do?
Which
I
part?
mean, those 3 readers.
Is this the right thing to, what do you mean?
When we read the paper, is that like skip that part?
No, it's a sin. So it depends on what you're doing. So the thing is that you're going to be reading a lot of papers, right? And for many of these papers, you've pretty much only seen the title, and you decided you didn't want to read it, right? And then for some of the others, you looked at the abstract. You thought, I thought this was relevant, but okay, they're working on totally different premises, so there's a different problem. And so you skipped it, right? And then some of the other papers, you'd be like, oh, this is more relevant. You start reading the intro, and you start reading the idea, maybe the conclusions, possibly related work and so forth. And then for some of those papers, you'd be like, I really need to understand this paper fully. I want to grasp the idea. And that's where you really delve into the details. Right? You don't do that for every paper. You do it when you kind of meet, when the paper is relevant enough that you need to, for instance, describe it in a related work. You want to understand the papers that you're describing in a related work.
So you're saying the reason for having that few number of people reading the detailed part is that most researchers are working on different areas, or and they are not lazy or have bad habits of not.
Right,
reading.
right. No, it's just the name of the game is that there's kind of a power law in like what's going to be most important to other people in your paper. A lot of people are more shallowly interested in your work. It's more superficially related to what they do. I'm not saying this is like your intended number of readers. This is the reality of like how many readers you expect to get for a different section. It's just relative, right? Make sense? Now you can try to make the thesis so exciting that everybody's going to read them, but it's a little bit tricky depending on what you're working on. More questions? So the abstract. Any thoughts? How would you do on the abstract?
Depends on where you submit it.
Okay. Hit me.
Some places have a general guideline, one thing is this.
Okay. Most conferences, in computer science at least, allow you to do whatever you want with your abstract. But there are kind of these, there's a well-formed, there's a craft to it. The craft is, state the problem, say why it's an interesting problem, say what your solution achieves, and say what follows from your solution. One sentence each. And yeah, you can expand it and maybe make it one or two sentences. For instance, if your solution does more than one thing, or if there's more than one implication from it, or if it's a really kind of convoluted problem, you need to describe it slightly better. But this is the bulk of your abstract. I'm just going to be short, yeah.
Can you explain like what the saying what follows from your solution is?
It means that because we did all this stuff, you're now able to do these things, right? Or it opens up an interesting area in this aspect, or you could imagine follow-up work in these areas. Right? Because ultimately that's part of your sales pitch for the paper. Right? Okay, so it should be brief. It should not assume too much. So it's a delicate dance right there. It highlights the items of importance. Now, it would make sense that you would just start by this, but in fact, most people write the abstract almost among the last things they do in the paper. It's not strictly true because it tends to be an abstract deadline a week before conference paper deadline, but in general, this is one of the last things that you finalize. And often I'm editing the abstract after everything else is ready. Because it needs to be kind of an accurate reflection of what your paper ended up being. Make sense? So here's an example of an abstract. Many papers are badly written and hard to understand. This is a pity because their good ideas may go unappreciated. Following simple guidelines may dramatically improve the quality of your papers. Your work will be used more, and the feedback you get from others will in turn improve your research. Perfectly fine abstract, even though it's a very cynical one, written by a clearly angry person. Yeah? 4 sentences. Now, you can deviate, of course, from the ideal. Like, I mean, if there's a particular set of assumptions you need to make, for instance, you need to expand on the context, like I said before, recap prior results because there's a lot of them, or maybe there's more than one result, that's fine. But you really what you're trying to do is to get people past your abstract and into your intro, right? It's like you're optimizing for clicks on the internet, right? It's clickbait, right? Except it's read bait or eyeball bait, right? You're in some sense a salesperson. You are in the marketplace of ideas. Your job is to get people interested in yours. Right? So, that was the abstract. What about the intro? So it's 1 page. First thing that it does is, let's describe the problem. Why is it interesting? What is the context? What is it, in fact? What is this problem? What's the first paragraph of your introduction? Usually starts with a topic sentence, that's a hook, and then goes into development. Maybe 2 paragraphs if you need to expand a little bit about the problem itself. And then, hey, what's new here? What did people do before? What do you think different? Why is what you do useful? What are some of the features of the solution? It has scalability. It has some other nice features that you'd like to advertise. And then, how do you know that this is the state? How do you know that it was scalable? How do you know that it was more secure? How did you evaluate it? Summarize your evaluation there. That's it. It's really 4 paragraphs, normally. And it ends with this contribution bullets. We'll talk about that. So the reader of an introduction has to be a general attendee of your target context. So, another person like yourself who's attending this. So here's an example of an introduction from programming languages. There are two basic ways to implement function application in higher order language, and the function is unknown, blah, 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 blah. To illustrate the difference, consider this. Here's an unknown function. How should the compiler deal with this call? Can't blithely apply this thing here, blah, 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 blah. So, in this particular case, there's another thing that needs to be highlighted here, which is that there's an example used to drive the introduction. When you're doing something very abstract, examples are key. So here, they took an example, it's like, oh, okay, we're dealing with these types of higher order functions like this one here, and here's a problem that comes up with. Okay, describing the problem. Stating your contributions. This is almost the first thing that you'd start by doing when you're working on a problem. Write your contribution bullets. How many contribution bullets do people usually put? I've seen more than that, but yeah, usually 3. Right? Why 3? It's a very good. It's a 2 is too few. 4 is too many. 3, right? It's a rule of 3. If you've seen anything from Steve Jobs, it's like all presentations, all these things. So somehow, like, it's just better to use the number 3 for all those different things. Like 3 options, right? So 3 contributions tends to be what people do for this particular aesthetic reason, right? So you might end up having a contribution bullet list that would be something like, hey, we come up with this particular idea, we present a model around this idea, and then we describe a design of a system that achieves this particular thing, and then we describe the results of our evaluation where we show that our implementation on in C or something like that achieves certain scalability, this, and that, right? Those are 3 contribution bullets describing a system. Example, right? This list of contributions, the reason why I start writing it early on in the paper is because it is driving the rest of the writing. These are your claims. These are your claims that if they were true, somebody would like your paper. And this is often a test for people who are reviewing your papers, that they go to the contribution bullets and be like, even if these were true, is this paper significant enough for us to accept? Be above the bar. And then you have to start to think about, okay, are they actually true, right? So, claim and evidence, we'll talk about that. So here's an example. We explain precisely what the 2 models are in a common notational framework in section 4. Surprisingly, this has not been done before. The choice of evaluation model affects all the way to identify this and discuss them in these sections. These are lots of blah, blah, blah. We make no apology, they're far from obvious. It's kind of an odd set of contributions, but pretty, they fit in really well. And you don't want to have your reader try to guess what you're really contributing. Like, is this new thing here, is it a contribution, or was that maybe done by in a previous paper? Right? All of that can be unclear unless you explicitly state it. So, another thing about contribution bullets is that they should be refutable points. So you don't say like, oh, we described the visual system, it's awesome. It's tremendous. Right? We give the syntax and semantics of language to support current processes, it's an innovative feature, something that people could say, yeah, that's not actually true. Okay? Falsifiable. We study its properties. Like, yeah, what does it mean? We prove that the type system is sound and that the type checking is decided. It's an irrefutable statement. Right? It's a section. We use this in practice. Okay, well, rather you should say, we built it up more explicitly. We built a GUI toolkit, we used it to implement the text editor, it's half implemented the Java version. It's an accurate description of what it is that you actually did. All right. And this is something I see a lot in conference papers. And this is how it makes me feel. The rest of this paper is structured as follows. Like, there's usually nothing surprising about the structure of papers. Why would you waste space? It's usually just a filler anyway. And I never read these. But it's like, section 2 motivates the problem. Like, you're just keeping me away from section 2 to be motivated by your problem. Why are you doing that? Why are you blocking my reading?
This almost seems like a substitute for a table of contents, and like I don't know how how else you're supposed to say, like, this is where you find these bits, like, titling the sections obviously is good, but.
Yeah, but it's kind of what your introduction should have done, is to give forward references to the things about what the paper's about. Your introduction is a reflection of your entire paper. It's about what is to come. So forward references instead, right? So instead of forward references to narration, the introduction should have surveyed the whole paper and forward reference everything that's important, right? So let's see if we need this. Yeah, so it's in other words, it's a capsule of the whole paper. The reason why I said the introduction should be one page is because they too should not be so long that they frustrate the reader. They should get to the point. They should be written as one page because that forces you to be concise in your writing. And it also means that somebody reads the intro and be like, oh, I'm still interested in this paper. Can't just move on directly to understanding the problem. This is the next thing you read, right? All right? Right? Okay. Fine. Okay, you don't want to frustrate your reader. Now, another thing about frustrating your reader, okay? Related work. You sometimes see this in papers, right? You have your intro, and then directly you hop into this like long historic exposition of related work, right? Everybody seen this?
Yeah.
It's like somebody, like this really old person sat down, well, in 1920, like, oh, why do you have related work there? You're breaking the flow of your paper. Unless you like absolutely necessarily need to have an exposition of all the things that have been done, it should almost be along the last, right? You can explain all the relevant bits from related work in describing a problem or in your introduction and so forth. You probably don't need all of it right there. This feels out of place, right? It's a wall between your reader and your idea. What?
Before you talk, sir.
Yeah.
What if they ask for it? Because they have
Who asked for it?
the reviewer. They
Yeah.
follow some rules and say, where is your related work?
Well, you need to have a related work, but just not here.
Yeah,
We'll move it down here.
Oh,
I'm just moving it. I'm not saying eliminate. Okay, I set it on fire in this location, but it has already been flown over here. Yes, I don't want to burn all the related work. I'm not that kind of a guy. Okay, no, related work absolutely needs to be in a paper. Just not there, because you're trying to go through the paper in a good way. It's a wall between your idea and your reader. Okay? So, here's for instance, like, we adopt the notion of transaction from Brown, we modified distributions by Y to 74-point interpolation, a work differs from Y. Like, I mean, this is just too long to put it there. It's not relevant to what the reader's thinking about at this moment. Right? The reader doesn't know anything about your problem yet. They only know what you've told them in the introduction, so they haven't even gotten to the section that's titled problem or motivation, something like that. So you're really blocking them from understanding. And therefore, they can't even relate to the things in the related work, right? And then like alternative approaches, like you haven't described your approach to begin with. It's not a good place for it. I think it usually fits dead last before conclusion. Okay, and yeah, this is how the reader feels here. The reader being an audience with feet. Okay? So, what if you're trying to solve like an open problem, something that's really well known? Well, you need to make sure that you're kind of informing the reader about the state of what's happening. Is this problem open? Is this problem solved? Is it unsolved? Was anyone deficient about the previous solutions? You are in charge of making the reader feel a certain way by writing. So if it is solved, or if it's unsolved, you need to kind of say that, right? If it's if people thought it was impossible, then maybe you'll write something like, it has been commonly asserted that it is an impossible problem to solve. See these references over here. However, we found that in blah, 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 blah. You're preempting the question, right? There's nothing worse than having a paper where the reviewer just gets blocked, or the reader gets blocked at some point in the intro, being like, no, this can't work, or you're not going to address this problem that I have, I'm just going to think about this one problem, I'm going to read through it, I'm going to be really judgmental. And if you never mention that particular problem, the reviewer is going to get really frustrated and reject your paper, right? So you try to preempt all those types of problems by just explicitly stating. including deficiencies of the stuff that you're doing. You don't consider a certain thing, or our thing, yeah, it takes up more memory, but instead you get these things, right? Just be honest about it instead of trying to brush it through, because somebody's going to detect it and they're going to be blocked by it, just like these things. The presenting related work and introduction can sometimes mitigate this problem. So in those cases when you have a really hard thing here, you really need to have an exposition related work, that's an exception to the rule. Okay? Refute points, forward reference to related works. Okay. So now there's a bulk here of paper, or most of the work actually lasts. No, that's actually not true, because if you think about the bulk in terms of number of pages, but in terms of the difficulty of writing, the introduction and abstract are absolutely the hardest things to write about your paper. I'm sure you guys have experienced this, right? Because you need to somehow relate it to like the rest of the world and draw people in, and you need to not make certain claims, and you need to make some other claims and so forth, just to kind of to frame the problem in a way that's useful. There's a really big school of how you write introductions, right? So there's what do you call this color? Yellowish set of things here. This is the bulky paper, but it's also the one that's more straightforward to write. Okay? Consider this idea. If you encountered a paper and this was the idea, how would you react? Like if I were reading a paper like this, I'd be like, consider right? Like, that's not an exciting way of presenting your work, right? You need to somehow convey the idea, right? Not just in writing it down like just blindly like this, but somehow in a way that people can relate to, right? So you want to be able to convey the intuition behind your idea. What should they be thinking about? Perhaps you need to describe the same thought in more than one way in writing, not just expressing the idea and like, okay, here's a concise way of writing it, but rather, suppose we have this thing here and write it out, and then let's write it more formally here. Same thing being written, it's just that you're leading the reader from the known to the unknown, gradually. Okay? So, once your reader has the intuition, she can follow the details, not vice versa, right? And even if you skip the details, which is like you're saying, a lot of people do, you'll still take away something valuable if you've invested in providing intuition. People will take the intuition from the paper. Right? So much silence. Wow. Whew, okay. It's excruciating a lot. Okay. Putting the reader first. Yeah. I know you did a lot of work for your paper. I know it was terrible. I know it was like you were dragged through the gutter, soaked with your blood, your journey of getting to that end destination, right? It's like Mr. Terminator over here, right? You're not going to present all of your rejected designs, all of your theorems that ended up not being actually true. It's like a little lemma. You're just going to kind of present what the reader needs to know, right? Now, this actually presents a bit of a challenge here in that when you read papers, you don't necessarily know exactly how the research was conducted. You don't know the route to it and so forth. And that's a pity. And it would be nice if there were more papers that describe, like, here's the exact journey that was taken to get to this result. And sometimes you can distill that from the actual talk. But often the case, you're getting bits and pieces of the picture, and the description and the narrative of the paper is like, look, we came up with this idea, it worked, and here's the design, and there's a magical design, even though there's like 30 redesigns, 20 rewrites, and so forth that happen to it. And that's just because we're trying to put it down into like a unit that's useful and reusable to other scientists, right? There's another venue for talking about the methodology that you use to do science. And this thing here, you're just trying to talk about your scientific idea itself. So yeah, it may be very tempting to put in here, we tried this, but it failed. Like, but maybe you don't need to, unless it's something that's an actual useful information to the reader. Right? You can write it for yourself, and you put it on your wall, just as a reminder. Harshness of writing. Right? So, most direct route to the idea. You're trying to be kind of expedient. You're trying to value the reader's time, right? Do you really need to inform them about all the obstacles here? Make sense? Cool. Examples. I had a horrible math teacher in my undergrad who thought examples were just the spawn of the devil. He wrote a linear algebra textbook that we took that had one example in it throughout. That example was quaternions. It was. There was never in the whole book was an example of a matrix written in matrix notation. It was always just an abstract symbol. Right? So you needed to have like a reference guide next to it to be like get any intuition from what he was talking about. That's an example of someone who doesn't use examples, which I don't want you guys to be. Introduce your problem, introduce your idea, and then develop the intuition for the reader through examples. Once you've done that, you can then take those smaller examples and talk about the general case. Don't start with like, here's the most general thing that you can do, because people won't understand you unless they're really pedantic, right? And like, I have to just see general cases, this is too specific. That's not really how people learn. People learn by getting examples and getting their intuition and then expanding on it. And that's also chronologically true. That's what happened when you did the research anyway. You try to solve a specific thing and then you realize, no, I could actually generalize it like this. Right? That's what happened. So present it as such. Here's an example. This is a background section right here. So set the scene for the paper. We begin with a brief overview of scrappy broadly proposed to generic programming. Blah, 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 blah. Basic algorithm is like this. So there's an example right away in this section. Makes it really readable. Imagine you're reading a textbook. It's kind of like how you would expect the text that could be formed. But what's cool about it is that you could actually take that example and make it into a running example. Expand on it. That's the best thing, right? So ideally, you would have something like, here's the first concept that I'm teaching you. And you're like, here's an example of that concept, just to make sure that you're with me still, right? Okay, here's the next concept. And now I'm taking the same example as before, and I'm expanding it with respect to the new concept, right? Does that make sense? You embellish your example. And then you keep expanding it as far as you can take it. Why is this useful? Well, if you structure it differently, for instance, you have like, here's a concept and another concept, and then finally like, oh yeah, by the way, here's an example of the first concept. You've lost the reader already, right? They're bored. They're probably thinking about something else while they're like going through your paper, if they have to read it, or they're reading about the paper, right? Example of the first concept, example and balance, right? This doesn't leave your reader on the train that you're trying to run them through. Or if you have first concept, example concept, next concept, then a totally different example. Well, that's kind of taxing on the reader to have to then re-visualize something completely different to understand your next concept. The running example is taking the same thing that you can expand upon. It's minimum cost for the reader. Make sense? Okay, extra effort. When you're writing your paper, you're making it a series of claims. This is actually a really helpful thing to do when you're writing the rest of your paper, is that the beginning of every section should really be a claim about what this section is trying to accomplish. Or maybe it's going back to the contributions in the very beginning. And the body of that section, or the body of the rest of the paper, is trying to provide evidence for those claims. Okay? So when you read your paper, when you're done writing it, you should go through and make sure that all the claims that are set out at the beginning, in the introduction, are actually addressed in the paper, and that you can even forward reference them from the introduction, and that you've provided evidence, either through a reference to somewhere, or by doing analysis, doing comparison, putting out that theorem, having some measurement about the thing you claim, doing the case study, bless you. Make sense? And then, different ways in which you could say the same thing. For instance, if you have some concept that might be difficult on your reader, like f of x is this function over here, you can say it twice in your narrative. What do I mean? I mean, you can say like, notice f of x is a weighted sum of the b's. It doesn't cost you anything to do that. It just makes it more clear, right? It lets the reader be like, okay, I think we're on the same page. Right? brings them with you. It's being gentle to your reader. Right? Claim and evidence, right? So yeah, I already talked about this. Here's an example of what I said. This section proves that the boobas approach the sound. We do this. This section shows that the boobas performs well under typical workload. Right? Can be a little bit boring reading papers that are exactly like this, but this is effectively what this should be like, because then you know exactly what the purpose of each section is, and it helps you with the writing, because then you know what you're setting up in the section. Okay, facts and conclusions. If you just write a series of facts, it's really upon the reader to try to distill a narrative from it, right? So really what you should, it's like you learn the facts of a crime and then you discover who did it. Like, yeah, it's a different genre of writing, right? So you don't want to have your reader try to guess what's important in your paper. But you need to bring them in, right? And one way to do that is something called a mental box, which is just to say that you have some concept, and you can kind of treat it as a black box from now. And you can say what it does without explaining what's inside of it. And then the reader will have that mental box of like, okay, there's this thing here, and there's this part here, okay, and then these things fit together. In systems, it's very obvious what those are. It's like, it's this layer, and then this kind of cross-cutting thing over here. You explain it, you can talk about it, you can talk about from kind of top down how these things interact, and then you can go inside the box and say, okay, here's how this box works. Because that's how people think, really. You have this kind of compartments. You don't have this like this kind of ocean, this big network of concepts. You try to have like a hierarchy of concepts. Make sense? Yes?
Not really. Can you give an example?
Give me an example. Did I put it? No, I took it out. So if you have, if you're describing the Google search engine, right? Then the way you try to go about it is that you could try to enumerate all the different things that are happening in all these different places, and you'll absolutely lose the reader. Instead, you can kind of go top down and say, like, you imagine that like the search process is like this. There's this layer, and there's this layer, and this layer. There's like the user, and then there's this layer that accepts requests, and then there's the concerts layer, okay? And then you can start talking about how this flows and some statistics between and so forth. Then you can say, like, in this section, we're going to expand on how this web layer here works. Now, you break it down into other mental boxes. There are these servers that talk together, and we'll then talk about them separately in different sections. So forth. You kind of go through this tree that you've created. But it's always well defined what's happening inside at every point in time. You understand the properties of the box. You don't have to know what's inside it yet. Make sense?
Yes, thank you.
More questions? I guess for related work, yeah. You don't have to make other people's work look bad to make yours look good. Just give people credit. So yeah, you can be like, in this inspiring paper, Google shows that blah, blah, blah. Just be nice. Yeah, if you don't give credits, it can kill your paper. Be precise in your comparisons. Conclusions, be brief. That's right. Process of writing. Maybe I'll just defer that to a second talk, since I have a lot of slides here. One of the things I just wanted to point out is, if you guys haven't read this book, The Elements of Style, it's really well written. It's fantastic, and it's illuminating in terms of the writing process.
And very old.
It's from 1920, and it's even more relevant today than it was then. Right? There's also Tufte's book here, or Tufte, I don't know the pronunciation, Tufte's book, The Visual Display of Quantitative Information, where he talks about how do you make those graphs? What do they look like? What do beautiful graphs look like? Right? And how do you express information? How do you lie about information? Why do people lie about it? For instance, here it's an example of like these numbers kind of grow, these bubbles grow, and they give this kind of, here for the camera, they give this feeling that things are growing faster than they really are, right? So you're trying to be dishonest with your actual graphics. It's a really good book. You can borrow it from my office if you like. One more thing I want to say here was about omit needless words. Just read this paragraph. This is the last thing I'll tell you. Vigorous writing is concise. So as you rewrite your paragraphs, try to get them to be this short. A sentence should contain no unnecessary words, a paragraph no unnecessary sentences for the same reason that a drawing should have no unnecessary lines and a machine no unnecessary parts. Think about just how concisely that is put. This requires not that the writer make all his sentences short or that he avoid all detail and treat his subjects only in outline, but that every word tell. Beautiful put, right? And that's kind of what you're striving for. You write and it can be a little bit kind of expanded. It may look like this. The object under study was displayed horizontally, yet the ball moved sideways. On an annual basis, yearly. Endeavor to ascertain, find out, right? You can go through your paper and omit these needless things over here. It should be considered that the speed of storage reclamation left something to be, the garbage collector was really slow. It's so much more clear, right? So simple, direct language. Oh, your references are not nouns. Can't do this. 3 didn't show anything. 3 is a footnote. It just says showed that. You want to say the system presented. Oh, you can't do that either. This is wrong. Oh, I have to fix the slides. The system presented by the list of authors, and then imagine these are actual footnotes. Okay, so summary, identify your key idea in your paper, make your contributions explicit, use examples, okay? And omit needless words. Great, thank you so much.